are coming from all over the country, from as far away as Hawaii. I'm from Florida. There are people from every place in between. Everyone is converging at this point today, and we sail on Sunday.
I'm Dave Kadko. I'm the Associate Director and Professor at the Applied Research Center at FIU. I'll be leading a group of 51 scientists aboard the U.S. Coast Guard cutter Healy to characterize the geochemistry of the Western Arctic Basin.
The Healy is the United States' premier high-latitude research vessel. This will be the first time we'll have an accurate baseline of what the health of the Arctic Ocean is.
This Arctic expedition in 2015 is historic in that for the first time there'll be 3 icebreakers from 3 different countries operating at the same time in different parts of the Arctic.
You know, it's an important project looking at the chemistry and biology of the Arctic before it changes too much more.
Yesterday the Healy pulled up and we're docked now in Dutch Harbor, and today was the first working day for the scientists allowed to come on and start setting up. And currently people are taking equipment and all their supplies out of the hold, and we're going to be bringing it up to the lab and finalizing the lab setup. We have to make sure everything is locked down and sealed.
We'll get this one done with
Seawater is collected and filtered next door in the Geochemistry van, and then it comes over to our van, and we look at methylmercury and dimethylmercury.
I'll be doing the analysis for nutrients on the water samples, and the nutrients include nitrate, nitrite, phosphate, and silica. And that's all done with this one instrument.
Right now we're standing in a clean room, which is used to process all our samples. The concentrations of the trace metals are very small in the ocean, and so we need to be very careful about the levels of contamination.
And that way we can turn it like this. Yeah.
Another very interesting and exciting aspect of this will be the amount and type of samples we'll be collecting. We're going to be taking samples from the ocean, from the surface ocean all the way to the bottom. We'll be taking actually bottom samples, the sediment of the bottom of the Arctic Ocean. We'll be taking aerosol samples. Aerosols are particles in the atmosphere. We'll be taking samples of ice, of snow, and of melt ponds, which form on the ice during the summer. So we'll be measuring about everything you could possibly measure on one trip in the Arctic.
And start the program.
This is an extremely exciting and historic development because the amount of data that's going to be provided will be enormous. It will take us years to get it all together, to interpret the data, to write it up. In the end, there'll be a huge archive of data that people will be using for generations to come.
This is it. After 6 years of planning, we're just 2 hours away of embarking on U.S. Arctic geotraces. It's been a very frenetic few days in port, but the crew of the Coast Guard and my scientific team are very competent. They've managed to put everything together. We're doing the final preparations before we shove off, and I'm confident that we're all ready to go.
Lifeline!
Going to the Arctic has never become routine for me. It is one of those unique mission sets that every day you see something different, and we're going to be underway for 62 days. It always remains novel, unique, and we stay on top of our game at all times.
The Arctic is a very forbidding, extreme environment. It's been very difficult to go there, to get data, to understand how it works. We're hoping that as we leave Dutch Harbor, that we'll be able to contribute to unlocking some of its secrets so we could try to understand how the Arctic will change in the coming decades.